Hello and welcome to this session of the Advanced Java course. In this session we will create a small little example for a REST controller. We will use Spring for that. That's why I have the Spring homepage open. We will be using Spring Boot today. It's this project up in the top in the middle. Spring Boot will help us really fast create an application. Spring Boot has an auto configuration feature which will enable all sorts of things later on. For example, if we want to use a database, which we will not do today. I prepared a little project here, so I don't have to type as much, and I will explain and talk you through this project. What I've done is I've created an animal controller, an animal service, and the Spring Boot application, as you can see here. Still a Gradle application, but I will talk about the classes first. So we have a controller. Let's start with that. You know MVC, this pattern for front-end stuff, where we have a model, a view, and a controller. We have a controller here. Spring provides us with a so-called REST controller. The REST controller annotation takes care of handling responses correctly, and it also is important for Spring to find this class. You remember dependency injection only works if in this context, the Spring context, the application context, knows of the Spring controller, of the animal controller. So that's what the controller part of this annotation is for. The REST part of this annotation, which makes it a REST controller, this one handles the serving of responses to clients. A REST controller is or has, of course, methods. It has a web interface, so I can call this function over a URI, and what I will get in return is some sort of HTTP transported content. So this content can be strings, it can be in JSON format, or it can be an XML format if I want to talk to a machine, and of course it can be an HTML format if I want to talk to a human. For all this to work, the REST part of the controller annotation is responsible. Now this is where Spring Boot really comes in handy, because I don't have to care about any of this. By default, a REST controller will respond with JSON objects to most of the requests. Only if I tell my request that I want XML, for example, then it will switch to the expected media type. Okay, so what have I done here? I've made a controller. This controller has, let's start with the mappings, with two get mappings. So I want this controller to answer on a URI path, which is animals. And I also wanted to answer on a URI path of animals.some parameter. The first two are get requests, the third one is a delete request. So we can make full use of all the HTTP methods here. So what does this do? Let's start with the get mapping of animals. If I want to call all the animals, I create a response entity. A response entity is an object. Let's take a look at the documentation with Control Q on Windows. Be careful if you try that out on a Mac. I usually hit Command Q, and people are usually not that happy about this. So the response entity is a wrapper object to take your status code, all sorts of headers, and a response body. So I can return, in this case I want to return my collection of animals, as you can see here, but I also return a status code. How do I do this? The response entity has a nice builder pattern, or in this case it's a static method, which is called OK. This will build up a header in this response status of 200, and we'll take this argument here as a response body. We will take a look at the animal service in a minute, but this is the architecture I've chosen here. So my controller calls a service, and this service does all the business logic stuff for me. In this small example, two things are obviously missing. We will take a look at that when we take a look at the animal service. I did not implement a database here, which would be a default case actually. And what I also didn't do was implementing tests for this controller. We will show you that in a coming up session when we talk about testing again. You already saw unit testing, and you already saw the basic stuff of unit testing and some advanced stuff. But what you didn't see, of course, is how you can test MVC controllers. The architecture is like this. I have this MVC part, so I have an animal controller, I have my model in the controller. The view is actually taken care of by Spring. Those are these response entities, so we don't really have a view here. We just have entities that we transport over the internet. So the first method is just a really basic method. It just takes the GET request, it's registered on the URI path animals, and it will return my animals from the service. The next one is a little bit more interesting. Here we have a parameter. These curly braces mark a variable, and I can access this variable with the @path annotation, path variable annotation, sorry. Which means when a request for animals /some string comes in, Spring will take care of routing this request to this controller and exactly this method, because it can map this name. Which means you have to be careful when writing multiple methods with just one parameter. You have to take care of separating those methods really carefully. Spring also, when routing to this method, will take care of wiring this name here, this parameter string. It will extract this name or all this part from the URI that's behind this slash and pass it on to this name variable. Which means I can call my getAnimalByName method from the animal service. This method returns an optional of animal because maybe this or no animal with this name can be found. So I've made this an optional. Because it's an optional, I can use the map function of optional, and if this animal exists, I can pass it on to the OK function of, or the OK method of response entity. You've seen this before up here. Now on here or up here I passed a collection of animals. Down here I'm passing just one animal, the one that got returned by the name. Of course, there only has to be one animal with this name, so that's a trade-off at this point. We'll take a look at the implementation if that's right in a second. The orElseGet function, or method of the optional, just is called when or in case that this optional is an empty optional. So let's say my getAnimalByName with a certain parameter name does not return any animals, it does not find any animals. It returns an empty optional, and the orElseGet function or method takes a lambda, which is a supplier. That means I can take this response entity not found. Let's take a look at that again in the documentation. So as you can see, this returns an headers builder. So the response entity also has some subclasses. This static function not found gives me a header builder. I could build up more header parameters, like location, for example, or even I could even set a status code by myself. And if I call the build method of this header builder, it will return a response entity for the current generic up here. So that's my get mapping for one animal or all animals with a certain name. I will return only one animal here. Let's take a look at the delete mapping. So the routing of Spring takes care of methods too. You can see I have the same URI signature, but I have a different HTTP method here. So Spring can take care of that for me, and it will route to this method if a delete call is made to this path. Again, I can take the path variable, extract this name into this variable here. I can now I want to delete this. My animal service has an remove animal method. You can see it here, but it takes an animal, of course, so I cannot remove anything that doesn't exist. What I have to do first is search the animal by name. If it's present, so if an animal was found, I can call the remove method, and it returns a Boolean value. So if you take a look at that, it's a Boolean remove animal, just one animal. If that was successful, I will return an OK. And if it's unsuccessful, I will return a bad request. If the animal is not present, this curly brace ends here, I will return a not found. So that's all there is to this REST controller. Yeah, let's call that in a browser. Oh no, we do that later. Let's take a look at the animal service first. So the animal service now takes, or it creates animals. So let's take a look at an animal. I created an interface animal, just has two methods, talk and get name. I already used them in the last clip for this session. Just some simple modeling of an animal. If you think about databases, you will have to do a little bit more. Of course, you could use an interface to declare those animals, but mapping those to actual database entities will be a little harder. But we'll look at that at a later point in this lecture. Okay, so back to the animal service. I've created a little animal store up here. I've called it, I called the collection of animals here. Used arrays as list and created some anonymous inner classes for this animal interface. So we have two dogs, woof, they make as a sound, called Poppy and Molly, and another animal, Molly, which makes meow. Should be a cat though. Here's my get all animals. This just returns this collection I created here. Easy one, get animal by name. It handles the case that this name is null. So I create an optional of nullable to use flat map afterwards, because I want to find out the first animal I can find in my list with a certain name. So here you can see how I implemented this to take care of returning an animal with just one animal, even though in my store there are multiple animals with the same name. What did I do here? I used the flat map, so this optional of nullable, this animal, this name that comes in here, I can use this name here. I map this name to stream, which I then filter, and of which I return the first thing, because this is a stream. And to find first, I can use flat map here to flatten this out. So this is actually an optional of a stream. And this find first returns an animal, because the animals are in the stream. So this would be an optional of animal, which is exactly the thing that I want in the end. I use the equals ignore case method on the names itself, on the strings. So this n is the string that comes in here, mapped it to n, comes down here. This a is an animal from the stream, So you call the getName method of this animal, and I compare those names. I created an addAnimal in the removeAnimal function or method. I did not call the addAnimal in the controller, but that's an easy one. I did not create updateAnimal at all, but of course you can do that too, which makes it a post and a put in the addAnimal controller. And they just operate on my little collection here, which maybe you can already imagine is easily adaptable to storing things to a database. So maybe we'll do that later on exactly in this example. Okay, but we are doing a Spring Boot, and I still want to show you how that actually works. For Spring Boot able to work, I need a dependency to my build script. So this Spring Boot Gradle plugin in a certain version takes care of certain things. It extends the dependency mechanism. That's one important part. If you take a look at the dependencies I declared down here, I completely left out the version numbering. So this Spring Boot plugin up here in a certain version takes care of wiring or of handling dependencies to other Spring Framework dependencies by extending it with the correct version number. Which means if I change this version number up here, all the dependencies will be in that version number. That's quite handy. Usually you have to hassle around with defining your own string of the version number you want and then replacing it in all those dependencies to take care of the problem when having more than one dependency. This one, or in this case, for compile and test compile, it would be easy and of course handleable, but if you think about having 4 to 5 dependencies to a Spring Framework, then it will become a hassle. So this dependency on the build plugin itself, which is outside of my project, makes it possible that my Gradle can now do more stuff. Let's see what it can do. I can call the tasks, and we will see in a second that there are lots of new tasks. Yeah, configuring. Of course, this build process always takes longer when the recording software is also running. Okay, so let's see. Start at the top, an application task, boot run. I applied the plugin Spring Boot, also applied the plugin Java and IDEA, but those are all. Spring Boot brings a boot run task, which just fires up the application if I have one main class. If I have more than one main class, I have to help the Gradle find the right one. What else do we have? What's new? We have boot repackage, which means I can take this project and pack it up as a jar or war archive. Nothing new down here. So all those tasks are default tasks. The IDE tasks are from IDEA plugin, and check and test are also from the Java plugin. So that's nothing new here. Okay. Those are default settings, some repositories, Maven Local JCenter, Maven Central for my dependency resolution, source compatibility, target compatibility, some groups, some version, dependencies for my project, and a Gradle wrapper so that I can use a certain version and don't depend on that, on the version that's installed. Settings Gradle just has the name of my root project. So that's the Gradle task, and that's almost all I need to do. Now, in order for dependency injection to run, I need to fire up an application, not an animal service, an application. And that's all I have to do. I have an application which has a main method, which uses the Spring application run static method here. Puts in my application class, this one, some arguments I gave, it came in from the command line. And the most important part is this annotation up here, the Spring Boot application. This Spring Boot application could also be called @magic because it does magical things. This is one of the very, very cool features of Spring Boot because it takes away all the configuration hassle you usually have. For a beginner, it is very, very easy to set up a Spring project that actually runs. That's all I have to do for this little project that you just saw to make it run. So my controller has a REST controller annotation. This Spring Boot application annotation takes care of the application context to be set up correctly and to be configured in a way that my REST controller actually can return JSON stuff. It also would take care, for example, if we have more starters. Maybe you noticed in the build Gradle that we use the Spring Boot starter web. So Spring Boot has many starter applications or starter dependencies, starter jars. I can put in a starter JPA, for example, or I could put in a REST MVC or something like that. And this pulls all sorts of dependencies, brings all sorts of dependencies with it. If you take a look at the external libraries that are in this project right now, with those two dependencies, you can see that's quite a lot. That's a trade-off, of course, if you have an auto-configuration Gradle stuff here or Spring Boot stuff, that has to be aware of many, many things. So it has logging for logback, it has Jackson stuff to make JSON, it has still faster XML, JSON path, it has some Vardin stuff in here. So all sorts of things, JUnit come from the testing part, all sorts of things that we need. And one other important thing is, because this is a Spring Boot application and we're talking about a REST controller, we have to fire up a web application. That's when we see a Tomcat here. So we have an embedded Tomcat, which is already configured to run on your local host if you fire up this boot application. Now that's really a cool feature. You can configure this, of course, so you can take some tweaks to the auto configuration. You can help it, for example, fire up a Jetty if you like Jetty more than Tomcat. But the default would be Tomcat. And setting up a database is almost as easy. You just drop in a dependency to a database and you drop in the starter for the JPA, for the Java Persistence API, and Spring Boot will create a database for you with that driver. How that actually works, we will take a look at in a later session. And down here we have some more logging frameworks, the JBoss validating stuff, logging, Hemcrest for testing, and down here all the Spring framework starts. So all the stuff that Spring needs to run. But now let's take a look at the actual application. So what happens if we call this boot run? I'll make the terminal a little bit larger here so that we can see what's scrolling through here in a second. So it compiles first. It was already compiled, so we don't have anything here. And boot run starts this Spring. Always makes a nice picture here in ASCII art. You can, of course, change this picture. And after a couple of seconds, the boot stays, or the Gradle task stays at 80% and says boot run. But as you can see, the application in a Tomcat started up. So that's the default, what you expect when running this task in a console. Let's scroll up a bit. We're starting an application on my PC. I don't have any profiles. I'm falling back to the default profile. Profiles are things that make dependency injection easy and configurable. A profile is used, for example, to set up a Spring context just for the test environment. Or another example would be if you have a staging area before you go to production, you can have a profile that uses a different database setting or different server setting for the staging area. It might have a different logging level and all those sorts of things that you don't want in production, for example. You can use in the staging area, or you can use in your development environment for your running tests. Okay, what happens next? The auto configuration starts up. It fires up a Tomcat. All sorts of Tomcat things. Fires up a servlet, right? Some filters. Looking for controllers. And now we can see what request mappings it found. So it found an animal's name with a delete method, and it maps it onto my controller, the delete animal method. This is a really nice way to verify that you've done everything right. You also have an animal's get, we have an animal's name get, we have an error. I didn't configure that, but Spring Boot did. So Spring Boot actually created an error resource that we can call through redirecting, for example. So we could, if we have an internal error, we could redirect to the error resource. And some other stuff that Spring takes care of at the startup for default servlet container. JMX is exposed on startup, so we can debug this running application. And Tomcat is running on port 8080 HTTP on the localhost. Okay, let's try that out. Of course, I prepared that already. Let's start with something we did not configure. If we encounter an error message, so 404, this application has no explicit setting or mapping for error. We saw some error, but it was mapped to the default, the basic error controller, which we did not configure in any way. So a white label error page is printed out. So that's actually what this controller does. But what we did was we called animals, and we can return a list of animals with the animals URI. The return value is a JSON array with 1, 2, 3 objects, 2 mollies and 1 poppy. Of course, it got lost here in this case, what sort of animal this is and what sound it makes, because this was just mocked actually. So I can also call for a molly. I can call for some animal that does not exist. So this is our not found. You remember we had a response entity in our animal controller. Animals get animal by name. So this one would return an optional empty now, and it would return a not found as response entity, which looks like an HTTP error 404 in this browser. Right, so that's how it works. It gives you a little bit of things to start with, playing around with REST controllers using the Spring framework, the entirety of the Spring framework. Spring Boot is one nice little feature to auto-configure all this stuff. And if you need it, it can repackage things for you. You already saw that we have a Tomcat embedded here. So I can actually repackage this project into one jar file, run this jar file on the server. It will fire up a Tomcat for me. So I don't need a running Tomcat and deploy a WAR file there. I can just take this jar, has a Tomcat included, run it on a server. This server could, of course, be a, let's say, Docker container or some other orchestrated container software, which means I can use it in the cloud and fire up lots of instances and use this as a deploying mechanism. for microservices, for example. So this would be a default use case. In the future, we will take a look at testing this REST controller, because this is quite interesting how to do that. We need to test those HTTP requests, mock those, and see that the return values are the correct things. And of course, we can use a database instead of this rather simple way of holding an internal list in the service. Okay, thanks for your patience. See you next time.